We are now done coding out our hash table, so let's discuss what its performance is like and some practical applications of hash tables. We have already gone over some of the performance aspects of hash tables in the first lecture of this section, but to reiterate, hash tables are an incredibly performant data structure. They have constant time insertion and lookup, which our linked list and our binary search tree cannot offer us. This is one of the most beneficial aspects of the hash table. In practice, hash tables can be used for a variety of different applications. Some examples in practice might be that your email provider could use a hash table to store all of your email addresses, just like we coded throughout this section. You could also use a hash table to store users in a database, where the key would be the user name and the value would be an object with all of that user's information. And you could really use a hash table to store data for just about anything. One drawback to hash tables, though, is that since the insertion of data is done in somewhat of a random way, determined by your hashing function, in a lot of cases, hash tables don't store references to other pieces of data in the data structure, unlike linked lists and binary search trees, which do. They reference previous and next nodes or children and parent nodes, etc. This functionality, of course, could be added to your hash table by placing specific properties on your hash nodes that reference other nodes, if you wanted to incorporate this. But overall, hash tables are an incredibly useful data structure, particularly because of their constant time insertion and lookup rates. That is it for our work with hash tables. I hope that you learned a lot about what hash tables are, what they are used for, and I hope you feel confident in coding them out. In the final video, we will be wrapping up this course. See you there.